I built a fully functional Omnitrix, and yes, it actually transforms. I could even play games on it with many other features. It took me 2 prototypes, one fried ASP22 C3 Super Mini, 2 months of my life, and yet somehow I finished it. Let me take you through how I built this thing from the very beginning. So it all started when I heard that Benton Dynamite was being announced. And the moment I heard Dynamite was coming, something just clicked in my mind. I thought, what if I actually built a real Omnitrix? Not a toy, not a prop, an actual working one. And I know what you're thinking, bro, just buy one. But what's the fun in that? So I grabbed my pencil, opened my notes, start sketching. And here's the first ever idea I got. So the first ever part I need to design was the dial. So I had this idea of using rotary encoder, simply making the dial as a big gear and the small gear connected to it, which is the rotary encoder. And some of you may think, wow, this is a great idea, but it's not. First of all, rotary encoder is chunky. Second of all, it needs so much accuracy. Third of all, I'm 3D printing the final model, and the gears will be weak as they are small length. And after some thinking, I got another idea. If I placed 8 conductive pads using copper tape in the side or at the bottom of the dial, and connected half of them to positive and negative, leaving the opposite remaining patches input to the microcontroller. The dial has a wire going in the curve of it, which bridges the input and the powered ones. By this method, it could read the left and right rotation of the dial, and this is much better than the previous one. I thought of making a mini version on a breadboard, so I used a 0.96 OLED display. And you may think how I am displaying alien icons on my OLED display. It is done by generating a bitmap of the image so the Arduino can understand what to display correctly. It is done by a website called image2cpp, in which you can upload the image and select your desired pixels and switch between black and white and hit generate, which generates a chunk of code which you can paste and use for your projects. Until now everything was going smoothly, and after some time I ran into a problem. The display I decided to use was GC9A017P. Even though the display was 1.8 inch, the PCB was 46mm length. And the worst part is the display is off center. So to cover the whole PCB, my dial need to be thick. Like the diameter should be 50mm, which will be not comfortable for a wristwatch. And this made me quit my idea. But I thought of using the OLED will be better because it's way more popular and small. So many people can explore it and even make their own one. So I switched to the 0.9 inch 128x64 pixel OLED display. I started making the prototype by rolling up a sheet of thin cardboard into a cylinder, just enough to fit my 600 mAh lithium polymer battery, TP4056 battery charger, OLED display and an RTC. And before I started doing more progress, I got an idea. When I saw the magnets I bought for an project which was supposed to be an foldable frame for lens, I got an idea in which I can put holographic sensor on the side of the body, and if the dial has a magnet, it can sense the rotation. For me, this idea was more personal because I thought of this. And also when using physical contact, there's wear and tear and dust will get in the way like the 90s ball mouse. So I stick to this idea. And I bought 3 of 49E 225 and stick them to the side of the body at 120 degrees between 3 of them. And tested them as they were analog, and the value under 600 was considered there are no magnets. And I tested the mechanism with LED cycling, and it was kinda working. And I made a more stable body by using a bottle which is somehow in the same size, and I made a mini cylinder with a magnet and covered the top so it would not fall, and it worked as expected. And the copper wires were attracted to the magnet, so I stick some copper wire to the body so the dial would not fall off, and tested again with RGB LEDs.
And later I also added the RTC, and that's the full montage of me making the semi-final 3D model. Okay, now I'll explain. That is the body which has the space to put all of its sensor. The dial is two-ported, one at the top which is hollow space, one at the bottom which also has a hollow space and where the main magnet goes. The body has extrude in which the hollow fits in, so the dial will fit in place. And this piece goes in the bottom of the body where the push button goes, and this part goes under the previous part. And I removed this extrude, which is unnecessary because I thought of using extra space for touch sensor, but nah, that's not comfortable for me though. And after 3D printing I came to know, because I'm using Ender 3 and the body has a big floating part, it's messed up and the extrude is too big and it's stretched, and the last bottom is so thin it broke. Also extrude of the body. I tried finishing this in this way, but it's way too bad for a comeback. So I know my mistakes now and started modeling the new one. I made the strap fitting holes which I made the bracket for, but I had better plans. Made the body better, made new dial fixing piece, added 2 new buttons, extended the dial, and that's it. But wait, the 3D models are in the description, but it's not fully the same as I made my final version. It also has imperfections, so I tell you about every part. The body is now clean with no magnet holes as they are not needed. These 4 pieces of the dial before installing the dial fit a 3mm length and 2mm breadth magnet into this piece, and also insert 3144401 Hall effect sensors as they have digital and they are easy to use. And place this piece on the top and this on the body connecting the top piece, and stick the top and this piece. Now take this piece and slide it right before the previous bottom piece and stick it to the body, not to the dial, to the body, and slide this after the previous one. Make so it touches the piece below the top piece and stick them together. Now you have a smooth non-takeable dial. And in the body the components go in this order: OLED battery, H32C3 Super Mini, and RGB LED in the remaining space at the bottom. Now place the 2 push buttons on the 2 grooves on there with connecting the buttons to these 2 parts, and place the push button facing downwards on this piece, also along with the TP4056 covering it, and a slide switch on the opposite side. Now place the completed body on this piece with this at the bottom and stick them. For me this part wasn't enough height, so I placed this dial piece from my last prototype and used it to connect, and also removed RTC as it's chunky. And let me tell you all the functions. First, when we turn it on, it is on the idle image, source like the Omnitrix, and in the idle mode there are 4 options which can be cycled by rotating the dial. 1 to the Omnitrix, second the time which needs to be set, 3 row wise animation which is by fluxgarage, you should check it out, it's on the description also, and 4 it's a game. And to set time you need to press the bottom button which is C for 800 milliseconds, and the time setting mode starts. When you press the other 2 buttons A and B, it decreases and increases the value, and pressing C again cycles through the numbers and dates. So after you cycle through all of them, pressing C again will make you set the time. And to play the game, you can start the game by pressing C and control the character by moving left and right using the A and B buttons. When you are in the Omnitrix mode and press A and B at the same time, you would go into the selection mode in which you can select all the 62 aliens available. And if you press the A and B button again in selection mode, it will get you into overdrive. If you press the A and B again in overdrive, it will unlock Alien X, the 63rd alien for you. And if you rotate a dial in the overdrive mode, it will get into randomized mode and select a random alien for you to use. And after you are transformed, after 30 seconds, it plays a power of animation using the LED and goes back to normal. And this is all about my Omnitrix project. I hope you liked it, and I'm 100% sure this is not good as I imagined, but as long as it's complete, I hope some of you seeing this will make a better version, and make sure to send it to me on Neonic Pulses on Instagram. I hope you all like this video and it's somewhat informative. I spent a lot of time making this project and more time than before for the video. So please leave a like and at least just leave a comment. So it kinda makes me know that people are actually giving attention to my content. And